Next topic is the MOT diagrams in heteronuclear diatomic molecules. So, hetero means here the molecule it is with different atoms are present. In previous examples we discussed about the O2, N2 and F2. So, in this molecule it is with the same type of the atoms. O2 molecule means 2 oxygen atoms and N2 means 2 nitrogen atoms. F2 means 2 fluorine atoms, means here same type of atoms are participated. That's why these are known as the homonuclear diatomic molecules. So, now we discuss about the heteronuclear diatomic molecules. So, now we see the first example, CO, carbon monoxide. Means CO molecule it is with 2 atoms, in which one is the carbon atom and another one is the oxygen atom. So, here carbon it is with 6 electrons and oxygen it is with 8 electrons. Total 14 electrons are present in that molecular orbital. Now, we go to MOT diagram of the CO molecule. So, here we go to the MOT diagrams. First, we go to lower energy levels. It is the 1s. And next is the 2s. And next is the 2p. Okay. Here, one is the carbon atom and another one is the oxygen atom. Already we know carbon at atomic number 6, so its electronic configuration is 1s2, 2s2, 2p2. And next oxygen it is with 8, so it is 1s2, 2s2, 2p4. It is the electronic configuration of the oxygen. So, means here it is the 1s2 and it is the 2s2 and it is the 2p orbital. Okay, in this 2p it is with only 2 electrons. And next here we go to the oxygen. It is 1s2 and next it is 2s2 and next it is the 2p orbital. Okay, in this 2p orbital it is with 4 electrons. So, next we fill the electrons 1s2, 2s2, 2p2 and here 1s2, 2s2, 2p4, 1, 2, 3, 4. So, these are the atomic orbitals. Okay, atomic orbital of the carbon and oxygen, they combine and it forms a molecular orbital of the MO molecule, means that is the CO molecule. So, now here these electrons, it is the bonding and anti-bonding of the 1s orbitals. Okay, it is the bonding of 1s and it is the anti-bonding of the 1s. So, first electrons are enters into the bonding now. So, from here 1 electron and from here 1 electron. So, total 2 electrons are enters into the bonding of the 1s. So, it forms the sigma 1s2. So, the remaining 2 electrons are there now. The 2 electrons are enters into the anti-bonding. So, first energy level is completed. And next we go to the second energy level. Okay, in the second energy level here carbon it is with 2s, it is with 2 electrons and oxygen is also with 2 electrons. So, in that 4 electrons, first 2 electrons are enters into the bonding. So, here it is the sigma 2s2. So, after that the remaining 2 electrons are enters into the anti-bonding of the 2s. Okay, 1s and 2s it is completed. Next we go to the 2p. Here in this 2p, so total how many electrons are there here? In carbon it is with 2 and oxygen it is with 4. Total 6 electrons are there. So, 6 electrons means first it enters into the bonding. After filling of the bonding only remaining electrons are enters into the anti-bonding. So that's why here these 6 electrons are enters into the bonding. It is the bonding 2p/2, pi2pz and sigma 2px2. Okay, it is a MOT diagram. Next, calculate the bond order. What is bond order? The total number of bonds present around that molecule is known as a bond order. So, how to calculate number of bonding minus anti-bonding? It gives the bond order. So, here how many are there here in bonding? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, bond order equals to, here bonding is 10 and antibonding is how many? In 1, 2, 3, 4. It is the 6/2. 6/2 means here it is the 3 is the bond order. So here it is paramagnetic or diamagnetic. How to explain? Based on the paired and unpaired electrons. All here these are the paired electrons. So paired electrons means here it shows the diamagnetic in nature. Next example is NO molecule. Okay, nitrogen and oxygen. So here NO plus. NO plus means here nitrogen it is with 7 electrons and oxygen it is with 8 electrons. Total how many electrons? 15 electrons. So here it is with one positive charge is there na? One positive charge means here we remove one electron. So then here finally this NO plus molecule it is with 14 electrons. Next we go to MOT diagrams. One is the nitrogen atom and another one is the oxygen atom. Next 2s. Next 2p. Okay, it is nitrogen, it is with 7 electrons now. So 1s2, 2s2, 2p3. It is 1s2, it is 2s2 and here it is 2p3. 1, 2, 3. And here oxygen. Oxygen it is with 8 means 1s2, 2s2, 2p4. Okay. So here we remove one electron from that NO molecule. We remove one electron. It is maybe from oxygen or it is maybe from nitrogen. Any one atom. So here we take the 1s2, 2 electrons, 2s2, 2 electrons and here we take the 2p. From here oxygen we remove one, then it is the 2p3. 1, 2, 3. Next we go to the MOT. First the electrons are enters into the bonding. So in these 4 electrons, first 2 electrons are enters into the bonding of 1s orbital. Next the remaining 2 electrons are enters into the anti-bonding of the 1s2 orbital. Next in 2s, first the electrons are enters into the bonding of 2s and next anti-bonding of 2s2. So next we go to the 2p3. Here total how many? 6 electrons are there. Okay, from here 3 and here 3. Okay, so in this 6 here, first it enters into the bonding. After filling of the bonding, the remaining electrons are enters into the anti-bonding. So here first the electrons are enters into the bonding. So here that electrons are completed now. So here it is the MOT diagram of the NO molecule. So here what is the bond order? Say bond order. Okay, here. So how many bonding orbitals are there here? 10 bonding orbitals and 4 anti-bonding orbitals. These are divided with 2. So then 6 by 2 means it is the 3 is the bond order, and here it is with paired electrons. There is no unpaired electrons. So here it is with paired electrons means here it shows the diamagnetic in nature. It is the second example NO. Next we go to the another example. CO is completed and NO is completed, and next one is the HF. HF molecule, that is hydrogen fluoride. See here, hydrogen it is with 1 electron and fluorine it is with 9 electrons. Total how many electrons? 10 electrons are there. Okay. So here we take the here hydrogen it is with only atomic number is 1 means it is with only 1 electron. So its electronic configuration is the 1s1, and here it is the fluorine. Fluorine here its atomic number is 9. Okay, here electronic configuration is 1s2, 2s2, 2p5. So here we take the 1s2 of the fluorine. It is the 1s2, and next here it is the 2s2, and next here it is the 2p5. Hydrogen it is with only 1, that is the 1s1. Okay. So here it is with 2 electrons, it is with 2 electrons, and here it is with 5. 1, 2, 3, 4, 5. Okay. So here in which hydrogen it is with only 1 electron. Okay. So here it is the pi 2py, pi 2pz, and it is the sigma 2px. See here, only one atom is involved now, and here also only one atom is involved. But here two atoms are involved. In the two atoms here, total how many electrons are there? Here hydrogen it is with 1 electron, and here fluorine it is with 5 electrons. Total how many are there? 6 electrons are there. So these 6 electrons are first enters into the bonding. Okay. So here it is the MOT diagram of the hydrogen fluoride. In this hydrogen fluoride, here there is no unpaired electrons, it is with paired electrons only. So here it is the paired electrons means here it is shows the diamagnetic in nature. It is the example of the HF molecule. And next last example, that is NO plus. Here nitrogen it is with 7 and oxygen it is with 8. Total 15. So here it is with 14 electrons. So one side we take the nitrogen and another side here we take the oxygen. It is the nitrogen and here it is the oxygen. So here it is the first and next is the second energy level. Nitrogen it is with 7, 1s2, 2s2, 2p3. It is the 1s2, it is 2s2 and it is 2p3. 2p3, 1, 2, and here oxygen it is with 8 electron, 1s2, 2s2, 2p4. It is the 1s2, it is 2s2, and here it is the 2p4. 1, 2, 3. Okay. Next we go to MOT. Molecular orbitals. first electrons are enters into the bonding of the 1s, 2 electrons, and the remaining 2 electrons are enters into the anti-bonding of the 1s2. Next electrons are enters into the bonding of the 2s, and next enters into the anti-bonding of the 2s2. So, here it is minus, means here we remove one electron from here. It is with only 3 electrons. So, then here total how many electrons are there? 6 electrons are there. So, that 6 electrons are first enters into the bonding. So, then here first it enters into the bonding. So, that is the pi 2p/2, pi 2pz2 and sigma 2px2. Okay, here also bond order same na, here bonding is 10 and anti-bonding is 2 divided with 2 means here bond order is 3, and here also it is with only paired electrons are there. So, here it shows the diamagnetic in nature. So, MOT diagram is completed.